My name is Cora Loucks, and I'm the Surveillance Coordinator and Data Analyst with the Ontario Ministry of Agriculture, Food and Rural Affairs.
And I'm Seyi Taylor. I'm the Product Manager for the Code for Canada team assigned to OMAFRA. Do you remember the story of the very hungry caterpillar? It ate and ate and ate for days until it got a stomach ache. Yeah, it's a cute story, and it's very, very cute.
But when it happens in real life, it isn't cute. The Western bean cutworm can cause farmers to lose up to 15% of their crop. And there are also ripple effects that cascade from this loss that can affect our economy and our food supply. For example, crop damage from Western bean cutworm impacts farmers' livelihoods and sources of income, but it can also impact the quality of the corn, making it harmful and toxic for animals like cows to eat, and so on, affecting the whole supply chain.
And it's not just Western bean cutworm. Many insects, pathogens, and weeds can decimate crops in a matter of days, costing millions of dollars to the sector. This is why crop protection matters. And this is where organizations like OMAFRA come in.
So OMAFRA stands for the Ontario Ministry of Agriculture, Food and Rural Affairs. In Ontario, we grow over 125 different fruit and vegetable crops. It contributes roughly $40 billion to the provincial economy every year. OMAFRA supports Ontario's agriculture and works to keep it competitive. Within OMAFRA, the Agriculture Development Branch, or ADB, is a team of specialists that work directly with growers. But we also work with other partners, such as industry, organizations, other governments, and academia to provide collaborative support to farmers. One of the most valuable and impactful tools in the crop protection toolkit is data. And that's things like pest counts, locations, temperature, humidity, trials, treatment, yield. It gives us the evidence we need to support the actions we take and the actions we recommend.
So let's dig a little into what that actually looks like. Meet Tracy. Tracy is an entomologist, which means bug scientist, with OMAFRA. Part of her job is to help farmers protect their crops from the Western bean cutworm. To do that, she's got to alert them to the presence of the pests, preferably before they get to the field.
So Tracy is the OMAFRA lead for the Great Lakes and Maritimes Pest Monitoring Network, which is a collaborative effort between the US and Canada. And it's made up of many different partners, including producers, academics, and extension specialists. At the start of the planting season, traps are set up by the network members. Every week, they count the number of Western bean cutworm moths that they've caught, and they all send their data to Tracy.
Tracy then analyzes the data she's received. She publishes it to the internet, and growers are able to use that information to determine when they need to take protective action. And the problem is that the data comes in different formats, and most often it's unstructured. Some farmers actually send in sheets of paper, yes. Some use a specialized app to send the data, and some farmers send an Excel sheet of compiled data, and none of it is formatted the same way. These are some of the most common errors Tracy has to deal with. For example, there's a latitude and longitude here. The first one is the Code for Canada office. The second one, if you make a simple mistake by missing a decimal, puts you right in the middle of the Pacific Ocean. So Tracy has to spend a lot of time reformatting, cleaning, rearranging the data before she can do any analysis.
Now, the raw data already gets to Tracy a week after the data was collected in the field. So this cleaning process means even more delays. And in that time, pest counts can double or even triple in the field and impact the grower's ability to control them. When it comes to protecting our crops, timing is everything.
There are lots of Traces at OMAFRA. Specialists work on over 100 data projects at the same time in different areas with different partners, and they all have different needs. On average, they spend a quarter of their time doing data collection, processing, and analysis. Now, as the Code for Canada team, we were tasked with working with the ADB to solve this problem. Our team was made up of Rola, Zola, and myself, and this picture is from before times when we could all go to the office. We kick things off by doing research, asking a series of questions in order to figure out the pain points and discover possible solutions.
And this was really valuable for us. The fellows taught us so much about user research, how to conduct effective user interviews, create user stories, and how to use this information to design a user-centered solution.
Our research showed a lot of challenges and some opportunities. So for example, there is no automated way for specialists to get weather data from external sources. So they have to manually copy and paste weather information from the Environment Canada website every time they need it. Because there's no central store of data, it can be hard for specialists to access data that they didn't gather. And because data is not validated before it's stored, specialists end up with a lot of errors and they spend a lot of time cleaning it. Finally, specialists spend a lot of time repeating the same analysis. Now, with all these problems, we couldn't solve all of them at once, but we did want to make a significant dent in the problem space. The vision is to make a system that will allow specialists to take data from multiple sources, whether direct entry or imported spreadsheets or via an API connecting to other apps. It should also allow specialists to decide how data is structured and provide tools to validate new data before it gets into the database. That way, specialists don't spend all their time cleaning it. It should also store data sets in a central database so that each specialist can access it, but give each one control over who can modify it in any way.
Enter Series. Series is a flexible, extensible data management system for OMAFRA specialists. Named after the Roman goddess of agriculture, Series is designed to revamp data management in ADB. Now let's see Series in action.
Okay, so this is Series, and I'm going to show you some of the features that have been built up right now. Now, in the past, when specialists created datasets, they didn't have the opportunity to decide what structure they were or some of the stuff that I'm going to show you. But now they can, and we'll show you why this matters. So let's say I created a new dataset called pest survey. Okay, and I had a description. This is a pest survey for a presentation. Okay, cool. Now I get to add new columns to this. So assuming that I wanted to add farm name, okay, I can decide that this farm name, I only want to get text in this and that it's required. So people can't leave it blank and they can't put in numbers. And then let's say I now wanted to add, what pest did you find? I go to data types and I can find pests as a data type. And I have a bunch of valid options that I can pick. So I'm going to pick, say, the Western bean cutworm because we've been talking about that, and the spotted wing Drosophila. I suspect that Cora is going to kill me for that one because I think that that's pretty unrealistic, but just bear with me. And now let's say I wanted to say how many pests were found. I can now say I only want numbers so that no one can type in TWO from when they meant to. And that's it. This is a basic data set. And now I can add items to it. So let's say I went to James's farm and we found 10 Western bean cutworm moths. That's it. I can't type in TEN, it won't go. Now let's say I wanted to add another item and I said, oh, I went to Peter's farm and I found, and I tried to type in TEN, that wouldn't work. So I found 30 of those and I can keep doing that. Now, let's say that I realized that the list of pests that was available to me was too small and that there were some other pests I wanted to survey, but I didn't have it in the list. Well, I can go to the admin panel and change and modify the global dataset of pests. And the global dataset is a dataset of things that are available to every specialist to be able to create. So I'm going to add a new one here. I'm going to add the fall armyworm. It's amazing how much biology you learn by working at OMAFRA. I recommend it if you're struggling with it. Okay, and that will now be available on the pest list going forward. And you can create new global data sets and they will be available as options. Now, if I go back to my data set, I'm also able to share it with other collaborators. So every specialist can see this data set, but no one can add to it unless I let them. And so I can decide to pick Cora and say, now you're a collaborator. And I can also add Zola and say, you're also a collaborator to this. And now they can come into the data set and add data to it and work on it. I've created a space for more collaborators to work with me. Finally, I can download the data that I want and it's down on my computer immediately. One other interesting feature of Series is that it protects data for about 30 days. So if you delete data like this, you can recover it for about 30 days. That means that we have better data protection and better data durability. There are other features planned for Series. For example, the ability to import spreadsheets or the ability to determine what your collaborators can or cannot do with your data sets. But this is kind of a sense of where it is right now. And we hope to see it grow up in the future. At this point, we've released the alpha version of the product. With this version, specialists can create data sets, enter new data, and share it with others. We've also provided OMAFRA with the documentation needed to guide development partners in building out all the other product features needed.
And we have a roadmap with a plan to get the beta version in the hands of specialists by next year.
When this application is live, we estimate it will save specialists about 30% in terms of time.
So what does this mean for Tracy? Tracy has more time to spend on value-add activities like field calls, presentations, collaborative research, and problem solving. And that's going to create a ripple effect as well, this time positively impacting the economy, the food supply, and our growers' livelihoods. Farmers are going to get the data they need to make decisions about how to protect the health of their crops faster. And as I mentioned, timing is everything. At OMAFRA, Series showed us what was possible. We saw rapid development, modern tools and techniques, and most importantly, user-centered design in action. These new skills are already changing the way we approach digital solutions in the ministry and the way we approach our everyday work as well.
We'd like to thank the Canadian Agricultural Partnership, a federal, provincial, territorial initiative that provided part of the funding for this project. We'd also like to thank the team at OMAFRA, without whom we wouldn't have been able to get any of this done, and the team at Code for Canada for their support. I'd also like to make a special shout out to my colleagues Rola and Zola and the entire cohort for all the support throughout this project. Thank you.